So for the following section, we're going to be talking about the law of cosines. And the law of cosines says given a side angle side or side 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 triangle, we have the following three formulas. At the end of the day, each of these formulas is the exact same thing, it just depends on which value you're solving for. So for instance, if you're solving for side A given side B, side C, and angle A, then you would use the first formula. If you're solving for side B, you would use the second, and for side C, you would use the third. Or if you're solving for angle A, you would use the first, for angle B, the second, and angle C, the third, just depending on which information you have. And just to note, a side angle side triangle looks something like this. You're given a side, you're given a second side, and the angle in between. A side-side-side triangle is pretty straightforward. You're given all three sides of the triangle, and you solve for the three angles. Okay, so with that, we're going to be given that side A is equal to 1, side B is equal to 1, and side C is equal to the square root of 2, and we're solving triangle ABC. So off to the side, we'll go ahead and make our list of all of our angles, as well as all of our sides. You can probably already guess the solution to this if you know about special triangles, if you have them memorized. But we're going to be using the law of cosines to solve this. So we need to solve for angles A, B, and C. We'll make a quick picture to make sure the law of cosines does apply here. So we were given side A is equal to 1, side B is equal to 1, and side C is equal to the square root of 2, which means we're solving for angle A, angle B, and angle C. So this is a side-side-side triangle, meaning the law of cosines does in fact apply. So how do we go about this? Well, remember when we dealt with law of sines, we said that you always want to start with the smallest angle or smallest side first, just because of the pattern that fits certain law of sines problems. The same is not true for law of cosines. You can start with any one of the angles you want or any one of the sides, because cosine only has one solution between quadrant 1 and 2, whereas sine could have two solutions between quadrants 1 and 2. But even though the law of cosines does not require you to start with the smallest side or smallest angle, I still highly suggest that you do. This way you always do the same thing, whether it's law of cosines or law of sines, so you don't end up forgetting which problems you have to do it on. If you always do it, then you don't need to remember which ones it has to be done on. So with that, we're going to start with the smallest side, meaning either A or B. It doesn't matter which one we pick since they're equal, so let's just go ahead and pick A. We're solving for angle A first, meaning we want to use this first formula. So A squared equals B squared plus C squared minus 2BC cosine of A. This is a pretty complicated formula when you first look at it. There are a couple of things that you can do to memorize this though. Notice if you don't look at this part, just look here. Does that look at all familiar? Hopefully it should in a way. This is the Pythagorean Theorem. A squared equals B squared plus C squared. You've probably more typically seen it as C squared equals A squared plus B squared, but it's the same thing. And all that's added on to it is this minus 2bc cosine A. And the way that this is generally taught to memorize is we already know there's going to have to be that cosine there. So all that there is to memorize is which values go where. So always remember, if it starts ABC, it has to finish CBA. So BC or CB, it's the same thing when you're multiplying. So notice ABC, CBA. So that's just a way to memorize this, but however you can commit it to memory, that's how you should do it. Okay, so getting back to our problem, now that we know the formula we're using, we know A, so we get A squared is 1 squared equals B squared is 1 squared plus C squared is the square root of 2 squared minus 2 times B is 1 times C is the square root of 2 times cosine of A is what we're solving for. So, simplifying this, we get 1 equals 1 plus the square root of 2 squared is just going to become 2 minus 2 times 1 times the square root of 2 is just 2 square root 2 times cosine of A. We can simplify from here by subtracting 1 and subtracting 2 from each side of the equation, which leaves us with negative 2 equals negative 2 times the square root of 2 times cosine of A. Remember, you have to take care of multiplication before addition or subtraction, so don't get confused and combine this positive 2 and negative 2. We can't do that because we're multiplying this negative 2 to the square root of 2 and cosine of A. And now from here, we'll divide each side by negative 2 times the square root of 2. When we do that, the negative 2 will cancel from the numerator and denominator, leaving us with just a 1 in the numerator. And the negative 2 square root 2 will cancel from the numerator and denominator on the right, leaving us with cosine of A equals 1 over the square root of 2. And now we can rationalize and solve for A. So to get that square root of 2 out of the denominator, we'll multiply the square root of 2 to the top and bottom, which gives us cosine of A equals the square root of 2 over 2. And finally, we can take cosine inverse of each side, giving us A equals cosine inverse of the square root of 2 over 2. That's 45 degrees. We don't have to worry about the fact that cosine can have a positive answer in quadrant 4 because there is not a triangle that has an angle in quadrant 4. With sine, there are triangles with angles in quadrant 2, but with cosine, only quadrant 1 will work. So 45 degrees is guaranteed to be our angle for angle A. And now that we're here, we can solve for angles B and C. And I know what you must be thinking. You're probably thinking, I really don't want to go through all of this process again for angles B and C. And the nice thing is, you don't have to. Because at this point, the law of sines can kick in. Because we have all the information we need to solve for angle B. Yes, it's not given information, which isn't a great thing. Whenever you can solve using given information only, you should technically do it. But for these law of cosine problems, I will make an exception. You can use the answers you've solved for as it saves a tremendous amount of work. So we're going to solve for angles B and C now. And at this point, it's important that we remember we want to use the smaller angle first, meaning the one that matches up with the smaller side, because sine can have an answer in quadrant 1 or quadrant 2. So we're going to solve for angle B first, since side B is smaller than side C. And we'll do that with the law of sines. So we get sine of B over side B is 1 equals sine of A, which we just solved for, is 45 degrees, over side A is 1. So sine of B equals sine of 45 degrees. And this isn't even a trigonometric problem. This is something we've done since algebra. Whenever you have two equations that are the exact same thing, then whatever is inside of them must be exactly the same. This, technically, with things like logs, that isn't always true, but in this case, this is true. If we take sine inverse of each side, we would be left with B equals sine inverse of sine of 45 degrees. They're just going to cancel out. B is going to be equal to 45 degrees. So we just have to solve for angle C now. And at this point, we no longer even need to use the law of sines, because now we have two of our three angles. Remember, angle A, which is 45 degrees, plus angle B, which is 45 degrees, plus angle C has to add up to equal 180 degrees. So if we subtract 45 degrees from each side 2 times, so we're subtracting 45 and subtracting 45 again, we'll be left with C equals 90 degrees. And this is why I made note that if you knew about special triangles, you probably knew the answer to this before even going through any of this law of cosines, law of sines, and then solving for the remaining angle, because this is one of our special triangles. Side 1 is 1, side 2 is 1, side 3, or the hypotenuse, is the square root of 2. And it's a 45, 45, 90 degree triangle. This is the exact answer. Notice we did not need to approximate at all to solve this problem. So for the next problem, approximation will be allowed to show how to do this using a calculator. So again, we want to make a list of all of the information we're solving for: angle A, angle B, angle C, side A, side B, and side C. We were given angle A is 30 degrees, side B is 4, side C is 5, so we're solving for angle B, angle C, and side A, and we're going to make a sketch of our triangle. Angle A, we'll put here, is 30 degrees. We'll put angle B here and angle C here. So side B is equal to 4 and side C is equal to 5. So notice we were given a side angle side triangle, which means the law of cosines does apply. So with this, which of our formulas should we use? Well, notice that we were given angle A. If you're given angle A and the two other sides, B and C, then that means you can solve for side A. So let's go ahead and do that. We have A squared equals B squared plus c squared. So remember, you put your Pythagorean theorem, and then you always put minus 2. Remember, you start working backwards now. C, then b, then cosine of what you started with, angle A. So filling in our information, we're looking for side A, so a squared equals b squared, gives us 4 squared, plus c squared is 5 squared, minus 2 times c is 5, times b is 4, times cosine of A is 30 degrees. And at this point, I know you must be thinking, well, we don't actually need to approximate at this because we know cosine of 30 degrees. And I'm going to take this a few extra steps just to show that approximation will actually be required here. So we get a squared equals 4 squared is 16, plus 5 squared is 25, minus 2 times 5 is 10, times 4 gives us minus 40, times cosine of 30 is the square root of 3 over 2. And simplifying, we get a squared equals 16 plus 25 is 41, minus 40 times the square root of 3 over 2. If we put 40 over 1 and cancel the factor of 2 from the top and bottom, we'll be left with 20 times the square root of 3. And at this point, if we take the square root of each side to solve for a, we get a equals plus or minus. We know immediately it can't be a negative because you can't have a negative side when your triangle is just floating off in space, when it's not on like a grid. So plus or minus, or really just plus, the square root of 41 minus 20 times the square root of 3. And this is why the problem says approximation is allowed. We don't want to leave this as our final answer for side A. Although it is technically an exact answer, this is extremely messy, and really we have no idea what this actually represents. Personally, if I looked at this, I would have no idea what this is even close to. So, when we plug that into our calculator, we get A is approximately 2.5217. Remember, we want to round to 4 decimal places. So we have 2.5217. And at this point, remember, we can now use the law of sines to solve this problem. It is going to be messy. It may introduce rounding error because we have a rounded answer. But remember, for these problems, whenever you have to go through using a rounded answer for law of sines, law of cosines, I'm okay with you introducing rounding error. But you can always use the answer feature on your calculator to avoid that. So if you have a TI-83 or TI-84, in the bottom right of it, you should see something in blue or maybe in black if it is its own button. I can't recall off the top of my head. That should say ANS. That means it is the exact answer you just had, and you can plug that in to wherever you need it so that you don't introduce rounding error. But again, I'm perfectly okay with you not doing that on these law of sines and law of cosine problems, as they're already complicated enough, and it's going to be a very small difference at the end of the day. So with that, we now need to solve for angle B or angle C using the law of sines. Notice we want to use angle B first because side B is smaller than side C. Smaller than side C. So we always want to use the smaller side first. So solving for angle B, we have sine of B over side B is 4 equals and we need to use A because that has the full information we need. So sine of 30 degrees over side A is 2.5217. We'll multiply each side by 4, or 4 over 1 since we're dealing with fractions. When we do that, this 4 will cancel out on the left, leaving us with sine of B equals 4 times sine of 30 over 2.5217. And we can simplify sine of 30 to just 1/2. So 4 times 1/2 over 2.5217. And at this point, you could simplify 4 times 1/2 is just 2. So we have 2 over 2.5217 equals sine of B. I'll just go ahead and write that off to the side here. Oh. And now, to solve for B, we will take sine inverse of each side. So when we do this, we get B equals sine inverse of 2 over 2.5217. And now we can plug this into our calculator. When we plug exactly what we have here into our calculator, it'll give us 52.4776 degrees. So that's what we're going to go ahead and put up here. But I do want to make an important note here. So this is our answer with rounding error. So this is what I'm okay with you using when you're dealing with law of sines, law of cosine problems, when you really have no other choice but to use rounding error information that you solved for. But if you wanted the exact answer, or the exact approximation, I should technically say, then when you type this into your calculator, you would actually type in sine inverse of 2 over ANS. This is the answer you got when you solve for A. So right when you typed in this, right over here, when you typed in this to get A equals 2.521 and so on, it should be a very long decimal. If you were to type in the ANS feature on your calculator, which should be the second button, and then the negative symbol, it won't show a 1 though, it should just be the negative in the bottom right of your calculator. If you were to hit this, it'll bring up this ANS feature on your calculator, which means the answer, and if you plug that into this formula, then it won't introduce rounding error. And in fact, it's very odd that it happens this way, but in this problem, the exact answer, or again, the exact approximation, is actually 52.4776 degrees. So in this problem, it actually ends up being the same thing no matter which one you use. So now that we have that, we can solve for angle C. And nicely enough, we don't have to go through any of this. Now that we have our two angles, we can find the third by just saying A, which is 30 degrees, plus B, which is 52.4776 degrees, plus C equals 180 degrees. I apologize if this is getting a bit messy, I just ran out of room. So we'll subtract 30 degrees and subtract 52.4776 0.4776 degrees from each side, to get angle C equals 97.5224 degrees. And that is the last piece of information we need to finish solving this triangle. Now it is completely solved based on the given information we had.